GATE aspirants, a grand welcome to Veda GATE Academy and a warm welcome to first subject in your GATE preparation, network theory. Before getting into syllabus, let me introduce myself. This is Shyam Sharma with 12 years GATE teaching experience. Taught this subject for different competitive exams like GATE, ESC and PSUs. Let's have a look into syllabus, DS. Shall we start? Yes. The very first topic in the syllabus, DC analysis. In DC analysis, first we go with basic definitions, Ohm's Law. Ohm's Law, dear, the origin of network theory is based on Ohm's Law. Network theory has started because of Ohm's Law. Next, K laws, Kirchhoff laws. Very, very important, yes. You can put in front star marks. The way we discuss K laws, in jet speed you can write the equation. It's my open challenge. In jet speed you can write the equations, dear. Whatever the sign convention you know, just leave it. The sign convention which I give here for KVL, follow that sign convention. Any circuit, any equation, easily you can write. Done, sir? Next, VDCD techniques means voltage division, current division techniques. After completing VDCD techniques, I will give one beautiful conclusion. A beautiful conclusion, sir. And I will conclude network subject as easy. Many will feel network subject as a bit difficult and confusing. But after completing VDCD techniques, yes, your feeling will change. You will also agree that network subject is easy for you. Done, sir? Next, series parallel reduction techniques. One more reason why many students feel network subject as a bit confusing. If you are not perfect with series parallel reduction techniques, yes, you will feel network subject as confusing. Almost in 1 to 2 hours, dear, I'll solve 100 plus objective questions. Then you'll get lot of confidence on series parallel reduction techniques. Done? Next, sources, sir. We have different sources, independent sources, dependent sources. The discussion will be done here. Next, VPL, not IPL, dear. It is VPL. Sir, what is this VPL? Verify power law. What is VPL, sir? Verify power law, which is nothing but Teligent's theorem. Sir, why you are discussing Teligent's theorem here? I have a reason of discussing Teligent's theorem before nodal and mesh analysis. Have reason, sir. Discussing Teligent's theorem and substitution theorem before nodal and mesh. Next topic we'll go with nodal and mesh analysis. Analysis of the circuit. We give a complete circuit and we'll do analysis. Analysis means what, sir? We'll find current and voltage of every branch. We'll find power of every branch. Once we have current and voltage with us, yes, we can find power. Next we go with source transformation. We have a condition. Source transformation can be applicable only for practical sources. We can't apply source transformation for ideal sources. Done, sir? Next, bridge problems. Bridge problems. Sir, bridge problems almost I discussed for 1 hour plus. Reason, I too teach measurement subject, electrical, electronic measurements for electrical students. Whatever the fundamentals that is required to discuss the topic, I will be covering here. Done, sir? I discuss these bridge problems only in electric circuits point of view. I don't introduce any measurement structure here. Done, sir? Next, some special problems like Q problem, finding equivalent resistance, infinite series network. Some special structures I will take and I will be discussing those structures here. Then I go with the theorems. Sir, up to here, I want to give one conclusion. In entire this basic DC analysis, what we'll be finding? We will be finding only 2 parameters, current and voltage. Once you have these 2 parameters, yes, you can calculate what? Power. In complete DC analysis, or I can say in complete network subject, we will be calculating only 2 parameters, 2 quantities I can say, current and voltage. That's it. The repeated question, current, voltage, that's it. Done, sir? Once you have current and voltage with you, you can calculate what? Power. Next, what are the basic elements that you have in this subject? RLC elements, resistor, inductor and capacitor. Resistor, inductor and capacitor. 2 quantities, 3 elements and 2 laws. I repeat, 2 quantities, 3 elements and 2 laws. If you want me to bifurcate further, Ohm's law is one law, KCL is one law, and KVL is one law. I can also say here 3 laws. Done, sir? Whereas if you look at globally, I can say Ohm's law, K laws, just there are 2 laws. If you are perfect with these 2 laws, if you understand the behavior of these RLC elements, easily you can find this current and voltage. For any structure, easily can find this current and voltage. Once current voltage is known, power can be easily calculated. Done, sir? Next, we go with theorems. What is the origin of theorems? When we have mesh and nodal analysis, when we have the analysis of finding current and voltage of every branch, why we are going with the theorems? What is the origin of theorems? So notice, response of a particular branch can be easily calculated with the help of theorems. Response of a particular branch can be easily, please understand this phrase, can be easily calculated with the help of what? Theorems. Whereas, overall analysis of the network can be easily analyzed with the help of nodal and mesh. We have different theorems here. Superposition theorem, Thevenin's theorem, Norton's theorem, maximum power transfer theorem, substitution theorem, reciprocity theorem, compensation theorem, Millman's theorem, and lastly, Miller's theorem. Sir, network's point of view, only 9 theorems. Network's point of view, only 9 theorems. But analog subject point of view, I do discuss Miller's theorem. If I discuss Miller's theorem, network's point of view, easily you can apply in your analog subject. Frankly, I want to say, if you are perfect with this DC analysis, easy students, analog circuits you can play like anything. Analog circuits problems and all you can do easily, sir. It's my challenge. Clear, sir? Next, lastly, DS, once theorems are completed, we go with capacitive networks, inductive networks, duality, and VI across RLC. Complete behavior of capacitor, inductor, I will be doing after completing the theorems. As told earlier, if you are perfect with RLC elements, yes, subject is easy for you. Done, sir. Next, duality. Why we discuss this duality? Duality, many will be thinking, resistor, what is the dual element? Resistor, dual element. Conductor, inductor, dual element. Capacitor, inductor, dual element. Capacitor. What is the dual element for power? Dual element for power. Please don't say energy. Okay. What is the dual element for mutual inductance? What is the dual element of charge? Charge dual element is flux. Okay. Right, sir. So, we have a reason of discussing duality. A beautiful reason. I will conclude once I enter into duality topic. Lastly, sir, VI across RLC. Very, very, very important topic, dear. Almost it takes some 2 hours plus to conclude this VI across RLC. Then, different waveforms given to inductor. Suppose, square waveform given to inductor. What is the shape of the output? Square waveform given to capacitor. What is the shape of the output? Like this, different discussions we'll be doing in this topic, VI across RLC. Fine, sir. Almost to complete this DC analysis including theorems, I take 30 to 35 hours. Minimum 30 to 35 hours I will take in completing DC analysis. After this 35 hours, any textbook, any problem, any competitive exam, it's my open challenge. Easily you can do, sir. Done. Next topic, DS, 2-port networks. Next, let's go with 2-port networks. In 2-port networks, what will be covering, DS? Different parameters. What is meant by port? What is meant by port? It's not either Krishnapatnam port or Vizag port. Port means pair of terminals we call as a port. Pair of terminals we call as a port. Fine. Different parameters are possible here. Z parameters, Y parameters, A, B, C, D parameters, inverse A, B, C, D parameters, H parameters and Z parameters. In your analog circuits, H parameter model you will be studying. H parameter model will be studying this. EC people, electrical people, in the transmission line, ABCD parameters. Transmission line for electrical students, even transmission line for EC students in your EMTL subject, electromagnetic transmission line subject, EMTL subject, you will be studying these parameters. Done. Z and Y, anyhow, common parameters, impedance parameters, admittance parameters will be studying theirs. Almost 2-port networks, very, very important, sir. If you are perfect with the 2-port, if you are perfect with K-loss, 2-port network problems, equations you can write fastly. Once you write equations fastly, solving and getting the answer. That's it, yes. Fine? Right. Almost 2-port networks, I will take 4 to 6 hours. 4 to 6 hours to complete these 2-port networks. Done, sir? Let's go with next part. AC analysis. AC analysis. First we go with AC fundamentals. Use black pen. AC fundamentals. Next, average RMS value. Here a beautiful interview question. When we have average value, why we have introduced RMS value? Why we have introduced RMS value? Beautiful interview question, dears. Next, form factor, peak factor. What is the significance of this form factor and peak factor? FF means form factor, PF means peak factor. Done, sir? Next, S-cube analysis. What is this S-cube analysis? Sinusoidal steady state analysis. STA. Steady state analysis. Come on, tell me. How many S we have? 1, 2, 3. We have 3 S. That's why I'm writing in short. S-cube analysis. Competitive exams, sir. We have to find shortcuts. Okay? Right. Next we go with theorems. Next, construction of power triangle. Very, very important. Yes, might be have listened. Sir, inductor, current lags voltage by 90 degrees. Capacitor, current leads voltage by 90 degrees. Why current has to lag in inductor? Why current has to lead in capacitor? Why? Why, sir? That analysis we'll be doing here. Next, coming to AC analysis. AC analysis, hope you all know, alternating quantity or the voltage or current quantity changing with respect to time. If it is changing with respect to time, why we are considering only sinusoidal? Why not we are considering or generating the square waveform? Why we are not generating triangular waveform? Why we are not generating quadrilateral waveform? Why we are not generating some parallelogram or something X? Why we are generating only sinusoidal waveform? Come on, sir. Why we are generating only sinusoidal waveform? This is one beautiful interview question. Next, we always go with represent any sinusoidal function either sin omega t plus or minus theta or cos omega t plus or minus theta. Why we are not going with tan or cot or cosecant? Yes. Why we are not going with these functions? Why always only sin or cos? A beautiful interview question, dears. A beautiful interview question. Why only sin and cos? Why not tan, cot and cosecant? Done? Right. All these points we'll be discussing in AC analysis. Done, sir. Why 50 Hz frequency? Why USA, American states are having 60 Hz frequency? Right. Next, let's go with power factor correction. Power factor correction. Very important, yes. Suppose the load is having a power factor of 0.6. If we increase the power factor load from 0.6 to 0.8, what advantages we are getting? Why the power factor of the load has to be increased? Has to be increased. When we increase the power factor of the load, what advantages we are going to get? That we'll be seeing in power factor correction. Next here, resonance. Resonance. Let me use red pen. Yes. Resonance. EC people, whatever the communication subject you are studying, everything that comes only with resonance. All wireless receivers works under the principle of resonance. So wireless receiver, wireless remote, yes, works under the principle of what? Resonance. Mobile phones and all, yes, works with the principle of what? Resonance. EC people, resonance topic, very, very important, sir. Series RLC circuit as well as parallel RLC circuit. Series RLC and parallel RLC. Here we have one question. What is that? This is the only topic where frequency will be variable. If you are discussing resonance, for sure, frequency of the supply is variable. No other topic frequency is variable, DS. Only at resonance, the frequency of the supply we take as variable. Next, not only that, we make circuit as purely resistive. Sir, how, sir? When you are taking a series RLC circuit, how can circuit can be purely resistive? Means, are we throwing inductor and capacitor outside? No, yes. We are not throwing inductor capacitor outside. Physically, inductor capacitor present, physically present, electrically we make it zero. Electrically, we make the presence of inductor capacitance zero. How we make electrically inductor capacitor zero, sir? That is what the beautiful discussion we do at resonance. Finally, somehow, we do some technique. We make circuit as purely resistive. So, when circuit is purely resistive, what is the power factor of circuit? Yes, unity. Once power factor circuit is unity, what advantages we are getting? What amplification we are getting? Series RLC, we get voltage amplification. Parallel RLC, we get current amplification. Done, sir? Right. Next, locus diagrams. Locus diagrams. Electrical people, EC people. Yes, electrical, sir, especially electricals. In your induction machines as well as in your synchronous machines, you'll be drawing circle diagrams. You'll be drawing circle diagrams. Just it's an extension of locus diagrams. Electricals. Induction machines as well as synchronous machines, whatever the circuit diagrams you draw, it's just an extension of locus diagrams. In power system subject, you'll be drawing power circles. You'll be drawing power circles. Just it's an extension of locus diagrams. I will make you perfect in drawing this locus diagram so that this induction, synchronous and power circles will be easy for you. I will take the responsibility, DS. Done? Next, let's go with next topic, transients. Next topic, sir, transients. If I use the word transient, yes, students will feel, sir, transients means it's a difficult topic. Strictly speaking here, it's a simple topic, easiest topic. Reason, we operate at t equal to 0 plus and t equal to plus infinity instants. At t equal to 0 plus, again inductor, capacitor, replace it with respective equivalent circuits. It's a simply a resistive structure. Again at t equal to infinity, after energies are fully stored or discharged, again we replace with respective equivalent circuits. Again it's a simple DC structure. Fine, sir. Transients, let me read the syllabus here. RC, RL, RLC circuits. RLC circuits. Circuits means again connections comes into picture. Series parallel circuits. RC, RL, RLC series parallel circuits with different inputs like step or DC, AC, step, unit step, ramp, parabolic, pulse, impulse, and exponential inputs. Hope you got the point, yes. DC, step, unit step. Yes, we have relation. Okay, right. AC, ramp, parabolic, pulse, impulse, exponential inputs. Whatever the analysis we do here, yes, electrical people, in your power electronics subjects, it will be useful for you. Complete power system subject, it will be useful for you. There you will do transient analysis of transmission lines. The transient analysis which we do here will be useful for UDS. Then whatever the AC transients we discuss, that will be useful for you. Clear, sir? RC, RL, RLC circuits. No other combination is possible. RC, RL, RLC. Series parallel combination. Yes, fine. With the different inputs. These are all the possible inputs. Any input here, triangular input. Yes, if you want to give triangular input, yes, you can give triangular input even. Any input you give here, we can analyze. That too in transients here, one important point I wish to say here. If the input is having a sudden change, Then we'll be discussing transient. The analysis is more. If input is changing gradually, output also changes gradually. Nothing to discuss. Suppose if you observe RAM, yes, how it changes? Like this. It's a sudden change or a gradual change? It's a gradual change. Parabolic, sir, gradual change. Pulse, yes. Impulse, yes, we have a sudden change here. If you observe, let me draw here. We have a sudden change here. A sudden change is there. Even pulse, yes, we have a sudden change here. If you observe here, yes, there is a sudden change. Hope you're reading the point. Step, sir. Step, yes. If you observe, let me use red pen. Here we have a sudden change. Here, sudden change. Pulse, sudden change. Impulse, sudden change. Means the transient analysis is a bit interesting for step input as well as for impulse input. If the waveforms are changing gradually, there's nothing much to analyze. Just a mathematical procedure. That's it. Come on, sir. Okay. Right here. Next topic, coupling circuits. Next topic is coupling circuits. Unfortunately, this topic is not mentioned in the syllabus, but the risk with this topic is this topic can be linked with the transients. This topic can be linked with AC analysis. This topic can be linked with the theorems. This topic can be linked with the resonance. This topic can be linked with any other topic in the subject. Is it done, sir? Right. Next, last topic, graph theory. Graph theory, sir. Very, very important, yes. Graph theory. Higher order circuits can be easily analyzed with the help of graph theory. Higher order circuits can be easily analyzed with the help of graph theory. Load flow studies in the power systems. Complete load flow studies. If you want to get perfection in load flow studies, compulsory a 2-mark question. If you want to get perfection in load flow studies, you have to get perfect with graph theory, sir. Done, yes? Right. Sir, coming to number of hours which you teach, yes. Let me get into next slide. DC analysis here, as said earlier, minimum it takes for me 35 hours. Next, if you ask me, sir, how many hours you teach 2-port networks, as said earlier, 2-port networks, minimum it takes 6 hours for me. Coming to AC analysis, including this resonance and locus diagrams, minimum to minimum it takes for me 25 hours to 30 hours. 25 hours to 30 hours I will be discussing AC analysis. Next, if you ask me transients, minimum it takes 15 to 20 hours. 15 hours to 20 hours I'll go with transients. Lastly, coupling circuits linking with all other topics, 7 hours. Graph theory, it goes with 3 hours. Done, sir? These many hours I will take to complete this subject. If we add all the hours, let me slide this down. Yes, 35 plus 6. 35 DC analysis plus 6, 41 hours. 41 plus 30, some 71 hours. 71 plus transient 20, 91 hours. Coupling circuits, 7 hours, some 98 hours. Graph theory, 3 hours. So, complete network subject goes with 100 hours plus. After this 100 hours, open challenge, yes, any textbook, any problem, any competitive exam question, easily can solve. That's my challenge, dears. Yes, it's my challenge. Easily can solve, sir. When we are learning all the topics, yes, easily can solve the questions. Done? If you ask me, in short, sir, entire network subject, what we learn? We know the procedures of calculating. We learn the techniques for calculating current and voltage. Once we know current and voltage, power can be calculated. How many elements we have? RLC elements. How many laws we have? Ohms law and K laws. Ohms law and K laws. Sir, yes, if I am compromised, if I speak locally, we learn the techniques like, see, any structure that can be solved either by voltage division, current division, nodal, mesh, source transformation, star delta, SPT, Thevenin's and Norton's. 80% of the subject, 80% of the structures we can analyze by these techniques. That's it. So yeah, if you say, sir, Millman's theorem, it's a replica of Thevenin's theorem. The dual of Millman's theorem is a replica of Norton's theorem. Fine, sir. Right. Here, even if you observe, see, thermodynamics 1, 2, 3, 4, 5, 6, 7, 8, 9. Just 9 techniques. 9 techniques. That's it. You take any problem, I will write this table, yes. I will write this table, and if possible, I will explain all the methods to all the problems. If not, I don't do this method. I don't do this method. Even I also explain why this method is not applicable, why this method is applicable, why this method is applicable. And suppose if this method is not applicable, I clearly give you the reason why this method is not applicable. Hope you're getting the point, dears. Right? Sir, it's a competitive exam. Competitive exam. And the questions in the competitive exam will be like, suppose if it is a multiple choice question, saying, we will be having 4 options. Out of 4 options, 1 option is correct. See, in my point of view, I say like, other 3 options also correct, but in a wrong method. Other 3 options also correct in a wrong method. Competitive exam, it's a trap. You may feel even other 3 options are also correct. Okay, other 3 options are correct in a wrong method. To avoid that confusion, sir, these are the only techniques that are possible to solve any structure. I will write this table for every problem, and whatever the methods that are applicable, I apply for that problem. If not applicable, I clearly give you the reason why that method is not applicable. Competitive exam, yes sir, you should know the perfect boundaries in the subject. If you are perfect with those boundaries, any structure, any problem easily can do. And I can say, network subject, I deal in such a way that if you are perfect with network subject, electrical engineering and electronics engineering will be easy for you. Then sir, electrical engineering, yes, network subject applicable in machines, power systems, power electronics, measurements, control systems, whatnot, any subject. If you are perfect with network subject, it's a just application of networks in other subjects. EC people, analog electronics, communication, signal systems, whatever the structures we are analyzing here, that will be easy for you. Even in signal system subject, the AC analysis which we do here, that will be helpful, dears. Is it clear? Right. This is what the introduction of the subject. Next, let's go with some reference books. Before getting into reference books, I want to make you people to write one note. What is that note? Very, very important, yes. You want to get perfection network subject? Yes. I am hearing some noise. You want to get perfection network subject? Yes, some students are saying, yes sir, I want to get perfection network subject. If you want to get perfection network subject, please write this note. Please write this note. I will tell you one exercise here. Just do that. What is that exercise? Write this note. Okay? Right. What is this note? To get perfection in network subject. To get perfection in network subject. Sir, even my notes available in the market. Yes, even if you open my notes, last year's notes and all, easily you'll find this note. Don't miss even a single class. Don't miss single class. See, if it is offline, I used to add one phrase here. Don't dare to miss even a single class. Don't dare to. Why? Because if you miss single class, yes, next class you can't understand. Suppose if you miss K-loss, no need to come to my class, dears. Why? Because my explanation is based only on K-loss. I explain K-loss in such a way that complete subject will be easy for you. Done, sir? Right. So, since it is an online class, yes, you can listen at any time or any place, n number of times you can listen. This is what the advantage we have with the online class. If it is offline class, I close the subject in 60 hours. Offline class, I close in 60 hours. Whereas in online, I will take minimum 100 hours. Done, sir? Right. Please don't miss even a single class, dear. You will feel the advantage in first 6 hours. Done, sir? Next. Reference books. Linear circuit analysis. I'm sliding this left side. Right, sir. Linear circuit analysis by D. Carlo Lin. It comes with Oxford University publications. Oxford University publications. Okay. Very, very important book. Next, Engineering Circuit Analysis by William Hayes, TMH Publications. What publications, sir? TMH Publications. Next, Fundamentals of Electric Circuits by Charles K. Alexander. Charles K. Alexander. Again, this is TMH Publications. Fourth book, Network Analysis by Van Valkenburg. Van Valkenburg. Just for reference, DS, don't buy any textbook. Okay. PHA Learning Publications. Last but not the least, Circuit Theory by Dosa. Not Dosa, DS, it is Doser. Okay. Right. Circuit Theory by Doser. Even this comes under TMH Publications. Sir, you have given some reference books. What we have to follow or what we have to see. D. Carlo Lean textbook, best textbook for theory. Next, William Hay, 5th, 6th, 7th, 8th editions are best editions. We have drill problems in this book. Please do those drill problems. Next, Charles K. Alexander, best book to solve unsolved examples and exercise questions. Unsolved examples and exercise questions. Fine, sir. Next, Network Analysis by Van Valkenburg. Let me slide this upside. Yeah. Van Valkenburg. Sir, if you want to get perfection with the 2 ports and transients, whatever the unsolved questions are there, in this Van Valkenburg, I will be solving DS. In my class, transients, 2-port networks, the unsolved questions of Van Valkenburg. We used to check any faculty, whether he is best or not in network subject. We used to give the unsolved questions of Van Valkenburg to him. If we solve those questions, yes, we conclude he has the best faculty. Done. Lastly, sir, Circuit Theory by Doser, exclusively for theory. Sir, given some 5 books, is there any requirement or necessity to buy these 5 books? No, DS. Okay. First book I have not yet given. If you are perfect with the first book, if you follow first book, yes, all these books are there in the first book. Shall I give that book? Shall I? Yes. Refer Shamsar notes for minimum 2 times. Listen to my explanation. See my notes for 2 times. Easily you can understand the subject. All these books combination, yes, you can find in my notes. Okay, whatever the best concept that is required, I will be covering this. Done? Right. So, not Shamsar notes, how it is available for us in an online course. I will be writing the notes for you and I will be sending the PDF file for you. Okay? Yes, the notes is written by me. Every point is written by me and I am sending to you, sir. No need to write any notes. Done, sir? Just look into this class, in online class. Please make some rough note. After that, yes, whatever the PDF file will be sending, just have a look into that. By looking into that video as well as the notes, please prepare your own notes. Please prepare your own notes, dear. Done? Perfect? Right. Now, let's go with the very first basic law in the subject, Ohm's Law. Sir, basic definitions, I have done a separate video and that video is posted in the Telegram group. In basic definitions, I will be covering current, voltage, potential difference, power and energy. That basic definitions, please have a look in that video. Now, I am directly going with Ohm's Law. Going with Ohm's Law, dears. The very first law in the subject, Ohm's Law. What is Ohm's Law, dear? The origin of network subject is because of Ohm's Law. The origin of network theory is because of Ohm's Law. What is Ohm's Law, dear? Writing the statement here. Current passing through a conductor, current passing or flowing through a conductor is proportional to potential difference applied across it. In brackets, very, very important conclusion here, statement. When temperature T is constant. Okay. Current passing through a conductor is proportional to potential difference applied across it in brackets when temperature T is constant. Why Ohm assumed temperature T as constant? We'll discuss a bit later. First, let us clearly analyze current passing through a conductor is proportional to potential difference applied across it. This is important, yes. Current. Writing the mathematical equation of this, yes. Current is proportional to V. Now you tell me, this proportionality is replaced with what? 1 by R. Proportionality is replaced with 1 by R. Now tell me, what is this R? What is this R, sir? Resistance. R means resistance offered by whom? It is not offered by some external element. It is offered by the conductor in which current is flowing. Offered by the conductor for the flow of what? Not water, dear. For the flow of current. Okay. R is resistance offered by the conductor for the flow of current. Sir, from here the real discussion starts. Very, very important, yes. Please have some enough patience in listening Ohm's law. Once I conclude Ohm's law, you'll really understand what is Ohm's law. The beauty of this subject is easily you can understand wrongly. Okay, I don't want you people to understand wrongly, dears. Please have some enough patience. Relax, buddies. Done? Right. From this I am writing, dears, V equals to I into R. What is R from this? R equals to V by I. Right. Now a beautiful question here. This V and this V, both same or different? Come on. Both same or different? Same only, na? Yes. Perfectly wrong. This V, both are not same. This V and this V, they are not same, dears. So then what is this V? This V is potential difference. Whereas this V is potential drop. Sir, Ohm's law is not I equal to V by R. I'm saying, see, understanding Ohm's law is not I equal to V by R. Not V equal to IR. What is perfect understanding of Ohm's law? If you understand the clear difference between potential difference and potential drop, yes, Ohm's law is completed. My intention to teach you the difference between potential difference and potential drop. Done, sir? Right. This V is potential difference. This V is potential drop. Next, what is this I? Current. What is this V? Voltage. What is this R? Resistance. What are the units of current here? So many amps, notated with first letter of amps A. Here units. So many volts, notated with first letter of volts V. Here units. So many ohms, but not notated with the first letter of ohms O. Reason, symbols problem. Already chemistry teacher used symbol O for oxygen. Then we are getting with some other symbol. This is what that symbol. Done, sir? Right. This is derived from the word omega. This symbol is derived from the word omega. Done, sir? Right. And one more doubt comes for the student. Sir, voltage representation V. Resistance representation R. Why not current symbol is C? Why not current symbol is C? Current is derived from the word intensite. What is that, sir? Intensite. What is meant by intensite? Intensity of electron flow. What is that? Intensity of electron flow. Intensite first letter is I. That's why current is represented with a letter I. Current is represented with a letter I. Hope you got the point, yes. Done? Right. So now let us clearly understand what is the difference between potential difference and potential drop. So to understand the real difference, I want to go with the physical representation of Ohm's law or physical analysis of Ohm's law. So a small question. Childhood, we like to go to school. Reason, whatever teacher teaches, he can show. Yes or no? Whatever teacher see. If you say he is apple, yes, teacher will show apple. So whatever teacher teach, he can show. That's why we like to go to schools and we love teacher like anything. That's why know every hour attendance. Whereas in engineering, whatever teacher teach, he can't show. See, teacher will say electric field from where he can show. Teacher will say current from where he can show. Whatever teacher teach, he can't show in engineering. That's why we don't like, we don't understand. That's why we don't like in going to colleges. Whatever teacher teach, he can't show. Since he can't show, we don't understand. Since we don't understand, we don't like going to colleges. That's why every hour attendance is required in colleges. Yes or no? Right. So even if I start discussing this current and voltage in terms of unseen quantities, you don't understand this subject. Okay. To give some better clarity in the subject, I want to introduce the physical representation of Ohm's law here. Sir, none of us has seen voltage. Have you seen voltage? Have you seen voltage? Huh? Have you seen current? Something going in this wire. Suppose feel this as a wire. Something is going in this wire. Can we say, sir, this is current? Can we say like this? Can you tell? No, not possible. Or by smelling. Suppose current is flowing. Sir, yes, beautiful smell. The smell is because of current. Can we say like this? No. Or by hearing. Something going in this wire. By hearing, sir, this sound is because of current. Can we say like this? Or by tasting, super taste, sir. Yes, this taste is because of current. Can you tell like this? No. If we feel shock, next minute we may not be here to experience our feeling. Yes or no? See, we can't smell, we can't taste, we can't hear, we can't see, but we can feel. If we feel, we may not be here to experience our feeling or to share our feeling. Okay, right. So sensors given by God is not useful in identifying current and voltage. So even if I start explaining in terms of unseen quantities, you may not understand this subject. So let us go with physical representation of Ohm's law. Done? Right. So let's go with the physical representation of Ohm's law. None of us has seen voltage, but everybody has seen water tank. Water tank everyone has seen, and level of water everyone has seen. Let me explain this, dears. This is tank, sir. This is tank, and there is some water in the tank, level of water. Next, here pipe is connected with a tap. If I open the tap, water starts flowing into bucket and buckets will start getting filled. Done? Here I want to give it some comparison. Level of water I want to compare with voltage. Level of water is compared with voltage. Done? Next. Come on, tell me, sir. Once you open the tap, what happens? Water starts flowing like this. Water starts flowing like this. And slowly, level of water in bucket gets increase. Level of water in bucket gets increase. Early morning, daily, same exercise, na? Same exercise or not? Huh? Right. So you tell me, dears, water flow in the pipe depends on this level of water or this level of water. Let me slide this. Hope it is visible to you, dears. Yes. Sir, it's an infinite sheet board. It is a digital board. It's an infinite sheet board. Sometimes I move left side, right side, top and bottom. It's an infinite sheet board. Maximum to avoid confusion for the students, we go with the next slides. Okay, sir. Sometimes if we move like this, example I'm saying, if we move like this, please don't get confused. Okay. Yes. Slowly we will rotate this. We'll make the board stable. Then only we'll start explaining. Done, dears? Right. Hope the board is stable for you. Shall I explain? Yes. So here, water is flowing. water flow is proportional to current. I want to compare water flow with current, level of water with voltage for easy understanding. Done? Yes. You tell me. My question here. We have written Ohm's law. I equals to V by R. I equals to V by R. Tell me, current flowing in the pipe depends on this level of water or this level of water. Come on. It depends on which level? Not this level. Water flow depends on this level. Matching na? I is proportional to V. Perfectly matched. Now here tell me please, what is your observations? I am writing here my observation. My observation here. Water flow allowed for some time. Water flow allowed for some time results in quantity of water in the bucket. I am writing here my statement. Water flow allowed for some time, results in quantity of water in the bucket. This is one beautiful statement. Water flow allowed for some time results in quantity of water in the bucket. Water flow is, I am comparing with what? Current. Results in quantity of water. Quantity of water, I am comparing with the charge. Okay, now tell me. Water flow allowed for some time results in what? Quantity of water in the bucket. Q equals to IT. We have one formula, na? Q equals to IT. Yes. Anywhere if you are seeing Q equals to IT, simply remember water flow allowed for some time into bucket. That's it. Next, one more observation here. Second observation, let me write here. Level of water in the bucket depends on level of water in the bucket. Depends on, come on, what, sir? Depends on what? Quantity of water and diameter of the bucket. Depends on quantity of water and diameter of the bucket. Quantity of water and diameter of the bucket. Okay, right. Observe carefully, sir. Level of water is compared with what? Voltage. Quantity of water, Q, diameter of the bucket. Okay, hope you all know this formula. V equal to Q by C. Come on, yes or no? V equals to Q by C. V is compared with the voltage. V is compared with the level of water. Charge is compared with the quantity of water. Now, this C I can compare with what, sir? Diameter of the bucket. Clear? Two statements. V equal to Q by C or Q equal to C into V. Next, third observation. Beautiful observation, dears. Third observation. Let me slide this. Hope the board is stable for you. Hope that pipe is visible to you, dears. Third observation I am writing here. What is this third observation? Come on, observe carefully, please. If diameter of the pipe is more, what is more, sir? Water flow is more. Water flow more means current is more. Current is more means resistance is less. Next, other way. If diameter of the pipe is less, hope it's visible to you, sir. If diameter of the pipe is less, water flow is less, current that flows is less, resistance is more. From this, what I can say? You please compare diameter of the pipe with the resistance and you tell me, please. Diameter of the pipe is inversely proportional to resistance. Hope you got the point. Diameter of the pipe is inversely proportional to what? Resistance. Observe please. Here, diameter of the pipe is more. If diameter of the pipe is more, resistance is less. If the diameter of the pipe is less, resistance is more. Hope you got the point, dears. Done? Is it clear? Are you comfortable with the three observations? You can do this experiment even on your own, dears. Done? Right. Now tell me please. I'm getting into this physical representation. Yes, now it's very, very important discussion here. So now please. When water is flowing through the pipe, some pressure will be developed between the water and the surface of the pipe. See how I am representing. Between the water and the surface of the pipe. Next, not only at the top, even at the bottom, some pressure will be developed across the surface of the pipe. Pressure developed between whom and whom? Between water as well as surface of the pipe. So, whatever that pressure we call as friction. The pressure we call as friction. Okay, sir. This pressure we represent with voltage drop. Hope you are reading the point, yes. This level of water we call as potential difference. Whatever the pressure that is developed between the surface of the pipe and the water, this we call as voltage drop or potential drop. Potential difference or voltage difference, same. Potential drop or voltage drop, both are same. Again I repeat. So now please, when water is flowing through the pipe, some pressure is developed across the surface of the pipe. That pressure we call as voltage drop or potential drop. Done, sir? Because of friction, that pressure is developed. That pressure we are calling as what? Potential drop. Clear, dears? Now you tell me, potential difference, potential drop, are they both same? All these days you felt that I equaled V by R, V equaled IR, both V's are same. They are not same, dear. This is what Ohm's law said. Ohms said potential difference is different, potential drop is different. Once I get into circuit, I'll clearly explain. This is physical representation. Hope you got the point. So this is potential drop, dear. Okay, right. So here the potential drop is represented throughout the length of the wire. This is what this representation is, a distributed representation, not lumped representation. That is distributed representation. I clearly explain what is distributed representation and what is lumped representation. Are you clear with this physical representation of Ohm's law? Come on, tell me please. What are three observations, sir? What are the three observations? Very first observation. Current passing through a conductor. Yes, water flow allowed for some time results in quantity of what in the bucket. Next, second observation. Level of water depends on what? Level of water in the bucket depends on quantity of water and diameter of the bucket. Yes or no? Next, one more observation. If diameter of the pipe is more, water flow is more, current is more, resistance is less. If diameter of the pipe is less, water flow is less, resistance is more. Diameter of the pipe is inversely proportional to resistance. Hope you got the point, yes. Yes. Next, observe carefully, sir. What is this C? Simply, we can represent like this. C, usually the values will be 1 microfarad, 10 microfarad, 100 microfarad, some 1000 microfarad. I can represent this like 1 microfarad means if you are comparing the diameter of the bucket, C is compared to the diameter of the bucket, na? Yes, I can say like it is like a cool drink bottle. Cool drink. It is like a mug. It is like a bucket. It is like a drum. We can compare like this. Okay. So, if capacitance values are increasing, what is increasing, sir? The diameter size is increasing. That's it. Okay. Right. Now, sir, can we represent this structure in electrical circuit format? Obviously, yes. Obviously, yes, dear. How we can represent? Let me slide this left side. How we can represent? Source, whatever the water tank water we are having, it is a source. Next, whatever the tap we are having, it is a switch. Water open, tap open, switch is closed, both are safe. Okay, resistance and a capacitance. The electrical equivalent of this circuit is this. Okay, K, switch is closed at some t equal to 0, say. What is this? R. What is this? C. Sir, how you are representing that R? Sir, I have a small explanation. Let me explain that first, or let me explain here itself. Suppose, right. Sir, any cubic centimeter, just a cubic centimeter of wire you take, it will be having around 10 power 18 to 10 power 23 electrons. Like just a cubic centimeter of wire you take, it will be having around 10 power 18 to 10 power 23 electrons. 10 power 7 means 1 crore, dear. 10 power 18 means some crores and crores of electrons are there in 1 cubic centimeter of a material. Suppose I am taking 1 cubic centimeter of a material, dear. Suppose I am taking 3 electrons like this, say. They are not idlis or bondas, dear. Hope you are all hungry. Huh? Right. Please have some time. Okay. Right. So these are some electrons, say. Okay. Fine, sir. When electron is moving from this point to this point, it has to overcome the surface friction. When electron has to move from this point, it has to overcome the surface friction. When electrons are moving like this, what happens, sir? Surface friction is there. Sir, here I am showing only 3 electrons. Just a cubic centimeter of material is having how many electrons, sir? 10 power 18 to 10 power 23 electrons. 10 power 18 to 10 power 23 electrons. Some crores and crores of electrons are there in 1 cubic centimeter of a material. Now what happens, sir? If you have crores and crores of electrons are there in this space, what happens? Obviously, when electrons are moving, collisions will take place. Collisions will take place. Collisions means when once collision is done, what happens? Kinetic energy is converted to heat energy. Kinetic energy is converted to heat energy. This surface friction phenomena, collisions phenomena, we call as opposition. What is the technical name for opposition? Resistance. Resistance. Resistance is offered by resistor, which is represented here. Next, even I have one more explanation, one more point to discuss with you, dears. Let me slide this left side. Yes. What is that? Suppose if I take a wire like this, it is having some cubic centimeters, some cubic centimeter. If you ask me RAB, throughout the length of the wire, we are having this resistance, dear. Throughout the length of the wire, we are having this resistance. This representation we call as distributed representation. Distributed representation. Distributed means what? Throughout the length of the wire, resistance is distributed. Throughout the length of the wire, resistance is distributed. Okay, right. So RAB, if it is some 1 kilo ohm, say, distributed representation. The same resistance simply can represent like this. 2 up, down, like this. 2 ups to 2 downs, or 3 ups to 3 downs. But don't draw like this. 1, it is wrong. Okay, 2 ups to only 1 down. Not correct. Wrong representation. Sometimes even in interviews, this type of questions can be asked, sir. Okay, right. 2 ups to 2 downs, so fine. Okay, right, yes. So this is this representation we call as lumped representation. What representation, sir? Lumped representation. Come on, you tell me which representation is good. Which representation is good? Lumped representation or distributed representation? Come on, engineers. Which representation is good? Lumped or distributed? Lumped representation is always good. Fine, sir. So we go with lumped representation, but not distributed representation. Got the point, yes? Yes. Next, observe carefully, please. Yeah, we are discussing this, right? Yes. So this is my lumped representation, a lumped resistor. So R value equals to what, sir? Rho L by A. Yes or no? Means If length increases, resistance increases. If area decreases, even resistance increases. Area decreases, resistance increases. Fine, sir. You will be seeing in your lab, electronics lab, small resistors. Area has decreased, resistance increased. In electrical lab, wire wound resistors are seen. Wire wound resistors are seen. Okay, right. So bigger of size, the value of resistance is less compared to small resistors. Even color coding will be there. Color coding, BB Roy of Great Britain, yes, has very good wife. Different colors, coding and all. Even I discussed how we will find that resistance by using color coding in the measurement subject. Done, sir? Right. Next, coming to capacitor, very important, yes. This capacitor, what is this C? Equals to epsilon A by D. What is epsilon? Permittivity. What is permittivity? Ability of the medium to allow electric field lines. So this epsilon we write as epsilon naught, epsilon r. What is epsilon naught? Absolute permittivity. What is epsilon r? Relative permittivity. What is epsilon r? Value equals to 1 for air. Epsilon r equals to 1 for air. What is epsilon naught? 8.854 into 10 power minus 12 farads per meter. So here, what is this D? Distance between the plates. What is this D, sir? Distance between the plates. What is this A? What is this A? Very important. Many will think wrong. As I said earlier, the beauty of this subject easily can understand wrongly. A means they will think area between the plates. Wrong. Area between the plates. Wrong. Area of one plate. Wrong. Area of both the plates. Wrong. Cross-sectional area. What is meant by cross-sectional area? Suppose if I am putting this pen like this, if you are looking from this side, this is what the cross-sectional area. What is surface area? If you are looking like this is what the surface area. Okay. Cross-sectional area. Wrong. Surface area. Wrong. How we have to understand this? Suppose I am taking here 2 chapatis. Okay. Both are of equal size, say 100 to 100%. Both are of equal size, say. Though here chapatis are not there, though they are of not equal size, please assume they are of equal size. Sir, you said chapati, hungry started. Okay, no problem, dears. Please wait for some time. Done? Right. Now, what I am doing is 2 chapatis I am overlapping. Example, see how I do this. I can select this. Yeah. See, I am perfectly overlapping. I am trying to overlap this. Observe. Hope you got the point. Yes. Now, what is this A? This A is nothing but, see, this overlapping area. This overlapping area. This is this A. Overlapping plate area is this A. Okay, na? Right. Next. Suppose, or need not to be all the time, need not to be like this, sir. Sometimes it can be like this. Sometimes it can be like this. Now, what is this A? Many will think A means this one. A means this one. Wrong. Many will think A means, let me use black pen. Many will think A means this one. Wrong. Many will think A is this. Wrong. What is A? Okay, let me undo this. Whatever the writing I have done, I am undoing it. See, everything it is going. Yes. Let me explain what is A. Yeah. What is A? This is A. This part is A. So simply we call like this overlapping plate area. Overlapping plate area is this A. A means overlapping plate area, but not area of the overlapping plates. Some will say A means area of the overlapping plates. Wrong. Blunder statement. What is A, sir? Overlapping plate area. Then, sir, 2 interesting points I want to discuss here. How the capacitor is formed. Sir, here this plate is initially at a neutral state, like a positive charge, negative charge, both are equal. Here, plus, minus, both are equal. Okay. Once it is connected to the supply, what happens? This positive terminal, it is having infinite positive charges. It is having negative charges. Now, what happens here? Once you give the supply to capacitor, whatever the negative charge we have here, that will be attracted by this positive charge. here this plate will become positive. Whatever the negative charge here, that will be attracted by the positive charge. Leftover charge here is positive. Now positive, positive, positive and positive. Now what happens? Whatever the negative charge we have here, this negative charge will come and stick here. This negative charge will come and stick here. Okay, at positive charge, no? Right. This negative charge will come and stick at positive charge, so that completely negative, 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 negative. This plate is completely positive. This plate is completely negative. Okay, sir. Now what is formed? Capacitor is formed. Now this element behaves like a battery. Suppose if any load is connected here, this is capable of delivering energy to this load. Hope you're reading the point. One interesting point here. Suppose if faculties, they will be drawing like this. Okay, they will be drawing that current flows like this here. If faculty draw like this, student will think like current flows through the capacitor. Student will think like that current is flowing here, which is wrong. I am undoing it. Sir, no current flows between the plates of the capacitor. If current flows between the plates of the capacitor, this is not a capacitor, sir. It's simply a short circuit wire. Current should not flow between the plates of the capacitor. Sir, to form the capacitor, what are the basic conditions? Two plates should be there. Two plates should be there, and there should be some distance between the two plates. Some here what should be there? Strictly speaking, some dielectric medium should be there. Dielectric medium should be there. Okay, sir? Right. So, current should not flow through plates. So, strictly speaking, what happens in the capacitor? What happens in the capacitor? Current flows. Let me erase up to this point. Yes. Yeah. Current flows like this, only up to this plate, and current comes like this. Electron flows, sir. Sir, electrons are flowing like this. If electrons are flowing like this, conventional current we take in this direction, which is explained in the basic definition. Next, electrons are flowing like this. Electrons are flowing like this means current is flowing like this, conventional current direction. Please don't think that I'm getting into other concept. No, yes, this is very important to analyze in the starting class itself. Current won't flow through capacitor. Just electrons flow like this, current flow up to here. Electrons flow like this, current comes like this. Now what happens, sir? What happens in between in this electric medium? This is what polarization concept, which I explained once I enter into transients. Third years, hope you all know about polarization and all. Here polarization happens. Because of polarization, the dielectric medium dipoles, they will be moving and all this story will be there, which I discussed there. Done? So, one small point, sir, I thought of telling you how capacitor will be formed. Yes, this is how a capacitor will be formed. I want to conclude this point here with one beautiful interview question. Let me take black pen. What is the efficiency of this circuit? What is the efficiency of this circuit? Let me slide this DS. Circuit still it is visible to you. Yeah. What is the efficiency of this circuit? Sir, answer I am giving 50%. What is meant by efficiency? Output power by input power into 100%. Or output energy by input energy into 100%. Hope you all know what is the energy that is stored by the capacitor. Stored by the capacitor, sir. Half CV square. Sir, answer I have given. Answer as 50%. Efficiency half CV square by dash. Then efficiency is 50%. Come on. What should be this? CV square. Energy delivered by the source is CV square. Energy stored by the capacitor is half CV square. Then efficiency is how much, sir? 50%. Energy stored by the capacitor half CV square. Fine. Okay. Energy delivered by the source CV square. How I discuss in transients. Sir, one more important point here. Suno please. Suno please. Very important. Very important. Please observe, sir. Energy delivered by the source. How much? CV square. Energy stored by the capacitor. How much? Half CV square. Half CV square plus dash is CV square. Now what is energy dissipated by this? Surprisingly, even this is half CV square. Surprisingly, even energy dissipated in the resistor is half CV square. Beautiful point, sir. N number of times asked in interviews. You go to any interview, the confirmed question is, what is energy dissipated by the resistor? How much? Half CV square. Why it is half CV square? So no, stay tuned to networks class till we get into transients. Stay tuned to networks class till we get into transients. In transients, I clearly prove why it is half CV square. Done, sir? Right. This is what Ohm's law, dear. Hope you got some perfection, some clarity, or some clarity in the difference between potential difference and potential drop. Done, sir? Let me go to next slide. So let me draw that Ohm's law structured. Yes. So this is what, okay. Let me draw Ohm's law structure. Resistor, a lumped resistor I am taking. Source I am taking, DS. This is V and this is R. So here, source, this is source. Source means my point of view, it is potential difference. Okay, right. Potential difference, source maintains some potential difference across the terminals of the resistor. Because of that potential difference, some current flows through the resistor. When current flows through the resistor, then friction collision will done, results in the form of a drop. Okay, sir. Right. Finally, this V is potential difference. This VR is potential drop. Find yes. Right. This VR is potential drop. Again, I repeat my statement. Source maintains some potential difference across the terminals of the resistor. Because of that potential difference, some current will flow. Once current flows through the resistor, collisions happen. Kinetic energy converted to heat energy. That phenomenon we call as opposition, which is nothing but resistive drop. Okay, potential drop. Yes. If you ask me, what is the value of this current? It is V by R. If you ask me, what is the value of VR? VR is nothing but I into R. VR equals to, what is I, sir? Substitute. V by R into R. VR equals to what? V. Very, very, very important conclusion. Doubt comes for the student. The basic doubts which students are having. Sir, when current flows from this point to this point, resistor will eat some current na, sir. How here current can be I? When water flows through the pipe, will pipe eat any water? Pipe won't eat any water. Similarly here, resistor won't eat any current. Hope you got the point, yes. Is it done? Next point please. Doubt for student. Sir, when current flows from this point to this point, current will be reduced na, sir. Dears, what circuit it is? It is a lumped circuit. Lumped circuit means this point, both the points are same. This point, both the points are same. Both the points are same, yes. Having any doubt? The same structure I can also draw like this. Both are same, yes. Got the point? Clear? Sir, after listening to my class, you should not have any doubt. Even should not have single doubt even, yes. Fine, sir. Right. Next, see, what is Ohm's law, sir? Current passing through a conductor is proportional to potential difference applied across it in brackets when temperature T is constant. Why Ohm assumed temperature T as constant? Huh? Did he discuss it with the sun and said temperature, yes, please be constant? Did he discuss it like that? No, sir. So what is the significance of this? Why temperature T is constant? Very, very important conclusion analysis here. Temperature T is constant. Why? Why he assumed like this? Sir, we all know this. Parameter values in brackets R, L, C depends on temperature. Depends on what, sir? Temperature. Next. Temperature is a parameter. Temperature is a parameter which depends on what? Which depends on time. Which depends on time. I repeat my statement. Parameter values depends on temperature. Temperature is a parameter which depends on what? Time. So I can't assume time as constant. Can I assume time as constant? Watch. Yes, please be constant. Means will it stop? No, sir. Okay. Right. Temperature I can't see. Time I can't assume constant. Temperature I can assume constant. If temperature is assumed constant, let me write here. If temperature is assumed as constant, parameter values are constant. Means parameter values are not changing with respect to time. Not changing with respect to time. Hope you got the point. If I assume temperature constant, parameter values are not changing with respect to time. So I can say system is what system? A time invariant system. System is what system, sir? A time invariant system. Why? Because though the temperature is changing, parameter values are not changing. What Ohm said, what is Ohm intention? See, V of t equals to, what is the statement? Voltage drop R into I of t. It is very clear from this equation, any change in V of t, if there is a change in V of t, for sure we can say this change is because of change in this. Why? Here R is constant. Any change in V of t is because of change in I of t. Yes or no? It is because of change in I of t. Next, if Ohm has given like this, V of t equals to, suppose if temperature is not assumed constant, now the equation would be like this. Any change in V of t is because of change in this or change in this. No clarity, na? Here equation is more complex to analyze. Here equation is more simple, dears. Ohm made subject easy for us. Okay, right. Since Ohm assumed temperature as constant, R is constant, with a simple equation only network theory has started. Suppose if Ohm has not assumed temperature as constant, if even this R of t is variable, network theory would be this much. Clear, dears? Right. So Ohm assumed temperature T as constant, meaning parameter values are not changing with respect to time, meaning system is time invariant system. So the further points here, what are the consequences by assuming temperature as constant? Let me take blue pen. What are the consequences by assuming temperature T as constant? The very first consequence, time invariant versus time variant system. Come on, tell me, sir. By assuming temperature T as constant, it is a time invariant system. It is a time invariant system. Right, sir? Next consequence, as distance value is not changing, linear versus non-linear. Sir, what is this linear and what is this non-linear? Many will say linear means superposition principle. If I ask what is superposition principle, they will say it as linearity. Let me give some clarity here. Even we have few objective questions in the previous GATE and competitive exams. Let us take a function x. Let us take a function f. If I am giving x as the input, you will be getting some output. What is this output, sir? F of x. X as input to the function f, you are getting output. Output is f of x. But background, it has a meaning. What is that? If this f is a network, if you are giving input as voltage source and current source, if you give input as voltage source and current source, you will be getting some output. What can the output? Or first tell me what different inputs that we can give. Voltage source, current source. Sources can be DC or sources can be AC. Still voltage dependent, voltage source. Current dependent, voltage source. Voltage dependent, current source. Current dependent, current source. Different sources, dear. I'm not discussing what is sources here. We have separate topic of sources. Okay. If you give these many sources, what happens? What happens, sir? You will be getting some output. What can be the output, sir? The output can be current. the output can be voltage, the output can be power, the output can be charge, the output can be energy, the output can be phase, the output can be frequency. Yes or no? Sir, in globally, if you ask me, what we'll be discussing? We will be finding this current and voltage. Once you know current and voltage, power can be calculated. If time is given, charge can be calculated, energy can be calculated. If AC supply is given, sir, then the scenario of phase and frequency comes into picture. So in DC analysis, we will be giving DC sources and we'll be finding current and voltage. That's it. So here, our topic, linearity, na? Yes. Here, observe carefully, sir. What is f of x1 plus x2? F of x1 plus x2 I can write like f of x1 plus f of x2. What principle it is? Additive property. What property, sir? Additive property, or I also call this as superposition principle. What principle, dears? Superposition principle. Next, what is f of ax? F of ax is nothing but simply a into f of x. What property it is? What property it is, sir? Scaling property. What property, sir? Scaling property, or we also call this as homogeneity principle. What principle? Homogeneity principle. Now here, if f of ax1 plus bx2 equal to a f of x1 plus b f of x2, if this principle is satisfied, then we can say linearity principle is satisfied. Means what is the conclusion, sir? Linearity principle, it is a combination of superposition principle and homogeneity principle. It's a combination of superposition principle and homogeneity principle. Yes. Done. Right. Let us draw one graph. Let us take some resistor and give some currents, voltages, and draw a graph and check the conditions of linearity. Sir, I am taking a resistor of 4 ohms, say. Fine, sir. I am sending some current. I will be getting some voltage drop, writing it as VR. Fine. Writing the voltage drop as VR. If you draw the graph, how we get this? Yes. Drawing the graph, yes. Taking y-axis, x-axis. From my equation, it is very clear. Ohms law equation. I am writing here. VR equals to I into 4. Here I is what? Independent variable. Here my VR is what? Dependent variable. Done. Taking current here. Taking VR on y-axis. Yes. You tell me. Suppose if 2 ampere current is sent. If 2 ampere current is sent, what is the voltage drop? For 2 ampere current, the voltage drop is plus 8 volts for 2 amperes. Suppose if 3 amperes is sent, 3 amperes is sent, 3 fours plus 12 volts. Suppose if 6 amperes, let me, yes, here, some 6 amperes is sent, 6 fours are, how much? Plus 24 volts. 24 volts. Suppose if current is sent in the reverse direction, if current is sent in the reverse direction, now you tell me, example, the same resistance, 4 ohms say, okay, right, if current is sent in this direction, I is like this or plus minus VR, plus minus VR. If current is sent like this, say, now what is the value of I? Minus 2 amperes. Or let us, you send on your own, you send minus 2 amps. Let me erase this current even here. Let me erase this current. Let me erase this voltage. Let me even erase this direction. Yes. If you are sending minus 2 amps, now what happens, sir? If you are sending minus 2 amps, what happens? With this polarity is plus minus 8 volts. With this polarity is plus minus 8 volts. Okay, right. Means for minus 2 amperes, you are getting how much, sir? Minus 8 volts. Suppose if you send minus 3 amperes, how much? Minus 12 volts. Minus 12 volts. So if you join the points, this point, if you join, yes, if you join all the points, it will be like this. 3 amperes here. If you join all the points, what you will be getting, sir? What you will be getting? A straight line passing through origin. A straight line passing through origin means for resistor, if you are sending current, if you are finding voltage and you plot this on a graph, the characteristics is a straight line passing through origin. Now let us check this straight line obeying linearity principle or not. Obeying linearity principle or not. Okay, sir. Right. Observe carefully, please. What is f of 2 plus 3? First, let us verify homogeneity principle or superposition principle. What is f of 2 plus 3? F of 2 plus f of 3. What is f of 2 plus 3, sir? F of 5. Okay. What is f of 2? F of 2 is available 8 plus what is f of 3, sir? 12. What is f of 3, sir? 12. What is f of 5? We have not yet calculated. Suppose if you send 5 amps here, what is 5 4, sir? 20. 20 equals to 12 plus 8, 20. Superposition principle is pakka satisfied. Next. What is f of 3 into 2? 3 times f of 2. Again, what is f of 5? 3 times, what is f of 2, sir? F of 2 is 8. F of 2 is 8. Done. F of ax. 3 times f of 2. What is f of 5? Again, 5 fours. 20. 5 fours are 20. Yes. 3 twos. This is ax. F of ax. A into f of x. F of 3 twos are 6. Na? Here we have written wrong. This is 6. Even this is wrong. What is f of 6? When 6 amps current is sending like this. What is this here? 24 equals to 24. Even homogeneity principle is satisfied. Now let us verify linearity principle. I am writing here. Let us verify linearity principle. Writing this left side. Yes. Hope this space is sufficient for me. How we verify the linearity principle, sir? F of 2 into or f of 3 into f of 3 into 2 plus bx some 4 into let us say some 6. Okay, right. This is your A. This is your B. What you can write? 3 times f of 2 plus 4 times f of 6. What is 3 2s are 6? Let us calculate. F of 3 2s are 6 plus 6 4s are 24 equals to 3 times. What is f of 2, sir? What is f of 2? We got 8 plus 4 times f of 6. What is f of 6? 24. 24. What is this? F of 30. What is f of 30? When 30 amps is passing through 4 ohm resistance, how much? 120. 8 3s are 24 plus 96. 120 equals to 120 means what is satisfied? Yes. Linearity principle is perfectly satisfied. Means what we can say? If the characteristics is a straight line passing through origin, means that the straight line obeys linearity principle. Straight line obeys linearity principle. Done, sir? Is it clear? Now, I want to give one conclusion here. All straight lines are linear. True or false? All straight lines are linear. True or false? False here. All straight lines passing through origin only linear. All straight lines passing through origin only linear. Done? All curves, whether passing through origin or not passing through origin, they are non-linear. Beautiful statements, dear. All straight lines are linear. False statement. All straight lines passing through origin only linear. All straight lines not passing through origin, non-linear. Non-linear. All curves are non-linear. Find here example of non-linear I am giving here. Sorry. Yes. Suppose the straight line is like this. Say. Yes, it is non-linear. If you are having any doubt, please cross-check with the property which is given. What is that? F of ax equals to f of ax1 plus bx2 equal to a of x1 plus bf of x2. That condition has to be satisfied. Then only we say it as linear. If you apply for this straight line, yes, That equation is not valid. For this straight line, the equation is perfectly valid, yes. Linearity, I have a question here. Small question. What is that? Linearity students used to apply for all the cases. Let me give some clarity here. One banana costs 2 rupees. What is the cost of 100 bananas? What is the cost of 100 bananas? Really, will you buy 100 bananas for 200 rupees? You will bargain. You will bargain. It depends with quality of the banana. It depends on condition of the banana. It depends in which area you are buying. Suppose if it is Hyderabad, yes, Koti, it is available at one price. Dilshuk Nagar at one price. If you go to Begumpet, it is available at one price. If you go to Jubilee Hills, Banjara Hills, it is available at one price. It depends in what vehicle you are going and buying. Walking means one price, cycle one price, scooter one price, car, Benz car one price. It depends on what time you are going and buying. Morning one price, late night one price. Yes or no? Right. So theoretically what is correct? One banana costs 2 rupees. What is the cost of 100 bananas? 200 rupees. Practically not correct. Yes or no? Right. Next, one more point. Daily read for 1 hour. You will get 60% of marks. Daily read for 2 hours. You will get 120%. Will you get 120%? Obviously no. Linearity principle we can't apply for all the cases. Linearity principle we can apply only when what conditions are satisfied. Superposition principle and homogeneity principle is satisfied. Done, sir? Next, one more important point here. One more important consequence. What is that? Lumped versus distributed. Lumped versus distributed. See, a distributed line can be represented as lumped R, L, C if the operating source frequency is less than 1 megahertz. If the operating source frequency is less than 1 megahertz, then only we can apply, then only we can represent distributed element into lumped R, L, C. Suppose if the operating source frequency is more than 1 megahertz, whatever the wire transmission is there, that wire transmission fails. Wire transmission fails. Wireless transmission comes into picture. What is that wireless transmission, sir? EMTL, electromagnetic transmission lines. Your waveguides acts like the transmission line to transfer the information from one point to other point. In cross-check DS. If the operating source frequency is greater than 1 megahertz, it is a wireless transmission for sure. It is a wireless transmission. Suppose if the operating source frequency is less than 1 megahertz, wire transmission comes into picture. Elements you can represent like lumped R, L and C elements. Clear, sir? These are what the consequences. What are the consequences, please? Time invariant versus time variant. We discuss what? Time invariant. We discuss theoretical part, but practical system is time variant. But practically time variant. But we are discussing time invariant system. Linear versus non-linear. Linear versus non-linear. What we discuss? We discuss linear. But life is non-linear. Lumped versus distributed. God is lumped or distributed? God is lumped or distributed? Huh? God is distributed. Distributed God, we converted into lumped idol. We go there and we pray there. But God is everywhere. God is distributed, yes. Okay? We discuss distributed or lumped? We discuss lumped. Fine, sir. We have two more definitions. Before getting into those two definitions, here one important point. What is VR? VR we have written as R into I. Yes or no? So what is equation of a straight line passing through origin? Y equal to mx. So the slope is nothing but what? Resistance. The slope is nothing but what? Resistance. Okay, right. Means if we calculate slope of this line, what we get, sir? Resistance. Having any doubt, cross check. Next, slope we are getting. This slope we are getting positive or negative? Here slope we are getting positive. Here slope we are getting positive. Getting positive slope means, yes, this resistor. Tell me, we all know resistor is a passive element or an active element? Resistor is a passive element. Resistor absorbs energy. From this I want to conclude. If we are getting slope as positive, that element absorbs power. That element absorbs power. If we get slope as negative, that element delivers power. Sir, see how I am linking. Here slope I calculated. I got slope as resistance. We all know resistance as energy absorbing element, energy dissipating element, power dissipating element. Slope positive means power dissipating. Slope negative means, yes, power delivering. Done, sir? Now let us go into two more definitions. Active versus passive. Before getting into these questions, let me, yes, slide this down. Suspense. As of now, these questions are suspense. Okay? In another 5 minutes, we are going to solve those previous questions. Done, sir? Right. Next. Active versus passive. What is meant by active element? Let us understand the definitions locally. Active means delivering, giving. Delivering, giving, supplying, we call as active element. What is meant by passive element? Absorbing, dissipating, taking power, we call as passive element. Yes or no? Right. Next, if you want to understand the definitions globally, yes, it takes some time here. Let me explain that. Examples of active element. Active element: voltage source, current source, diode after biasing, Okay. Next, even transistor, common emitter amplifier, etc. Op amps and all. All these are examples of active elements. Coming to passive elements. Resistor, inductor, capacitor with initial condition 0. If I am writing inductor, capacitor here, even I can also write inductor, capacitor here, active elements. Inductor, capacitor can deliver energy only up to 5 time constants. Why only up to 5 time constants? Transients, dear. Okay. Right. Active elements, inductor, capacitor can deliver energy up to 5 time constants. Okay. Here, passive elements means resistor, inductor, capacitor. Inductor, capacitor with initial condition 0. Next, diode. Before biasing. Sir, if we see locally, active elements, passive elements can be bifurcated like this. But if you see globally, from where this source is getting energy? From some other point. Example, see, I have 500 rupees with me. Say, I have 500 rupees with me. To give this 500 rupees to you, someone has to give 500 rupees to me. Example, I am saying one more time. Right. Suppose, don't ask me 500. Right. To give 500 rupees to you, someone has to give 500 rupees to me. From where that person has got 500 rupees? Some X person has given 500 rupees. I can't print 500 rupees on my own. Yes or no? Right. One more example I want to give here, sir. Suppose fan is rotating, say. In your rooms, fans are there, right? Yes. See the fan? Relax for some time. See the fan? Okay, fine. It is there. Suppose says from where fan is getting power? From the wire. Is wire giving power to fan? No. Background transformer is giving. Yes or no? Background transformer is giving. Can transformer give power on its own? No. Transformer has to get power from generating station. Is generating station giving power on its own? No. Example, you take Naganya Sagar hydraulic power station. Water is giving power to hydraulic station. Can water give power on its own? No. From rivers has to give water to dam. Are rivers getting water on its own? No. From where they are getting water? From rain. From rain rivers are getting? No. Clouds has giving that water. Hope you are getting the point here. So it's a cyclic process. Globally, if you observe, no element is active in this world. All the elements are passive. Hope you got the point. Yes, rivers from rain again from clouds. How the clouds are forming? Again the cyclic process. Clear or not? See, even many used to ask me here question, sir, common emitter amplifier. Yes, if you take a common emitter amplifier, if you are giving a sinusoidal signal, you are getting an amplified version. Common emitter amplifier, is it giving an amplified version on its own? No, dears. Amplifier here, what is connected? VCC is connected. DC supply is connected. Once you connect the DC supply, what happens? Conductivity changes. Junction junction activities changes. In a particular region, junction activities will changes. Then it behaves like a source. Common emitter amplifier on its own, it is not giving amplification. It is taking energy from someone and it is doing some process here. Yes, the amplification is done. Done, sir? So what I want to say here is, locally, we are comfortable with local definitions. Let us understand the definitions locally. That is fine. Don't go globally. Sir, how this source is doing means this has to get energy from some other, sir. If you think like this, globally, no element is active. All elements are passive. And the last definition here, bilateral versus unilateral. Very, very important. Many understand this wrongly. Even many teachers explain this wrongly. What is the bilateral and unilateral? If element conducts equally in both the directions, that element is a bilateral element. Suppose if element is conducting only in one direction, that element is a unilateral element. Best example for bilateral element, resistor. You have seen earlier in the earlier slide. Yes, conducting equally in both directions. Black wire. Conducting equally in both directions. Bilateral element. Not conducting equally in both directions. Conducting in both directions but not equally. Not unilateral and not bilateral element. Not unilateral and not bilateral element. Conducting only in one direction. Unilateral element. Conducting both directions equally. Bilateral element. Not conducting equally in both directions. Not bilateral and not unilateral element. Fine, sir. Now student used to ask a question. Sir, bilateral example you have given. Unilateral example you have given diode. But what is the example for a not bilateral, not unilateral element? Yes, this is, if you ask me, this is not bilateral and not unilateral element. Sir, which element will have that characteristics? Which element can have that characteristics? Charged capacitor and charged inductor will have such characteristics. Example, see, I'll explain here. Let me explain. Let me slide this. Okay, I don't want to slide this upside. Why? Because suspense questions are there here. Okay, right, surprise test. Fine, sir. Suppose a capacitor, it is having some initial voltage, say. It is having some initial voltage. Let us write some Vc of 0 minus as some 2 volts, say, before closing the switch. Let us say some switch is there here. Okay. Now what happens, sir? Now what happens? Yes. Let us plot the charge between Q versus V. Then initially capacitor is having initial charge of plus 2 volts. As source is given, what happens? As 10 volts is given, what happens? Slowly increases up to 10 volts. Even this V is there like this, say. Next, suppose if capacitor is driven with reverse voltage polarities. Here plus minus, sir. Okay, right. Here with these polarities, 2 volts is there. You are giving 10 volts with reverse polarities. Now what happens? Now what happens for this 10 volts? Slowly capacitor first discharges. 2 volts discharges to what volt? 1 volt. Next, 0 volt. Next, discharges or charges up to minus 10 volts like this. Now you tell me, sir, characteristics not passing through origin. Still is a straight line. Mass faculties will say all straight lines are linear. False. All straight lines passing through origin only linear. So which element has got this characteristic? Charged capacitor. Charged capacitor. Yes. Now you tell me please. This element, is it bilateral or unilateral? Not bilateral. Not unilateral. Not bilateral, not unilateral. Is it linear or non-linear? It is non-linear. Linear or non-linear? It is non-linear. Why non-linear? Not passing through origin. Active or passive? Calculate the slope. Slope is positive. Therefore, this is a passive element. This is a passive element. Sir, hope all the definitions are over. Only 3 consequences by assuming temperature T as constant. What are the consequences? Time invariant versus time variant. Linear versus non-linear. Lumped versus distributed. I have given 2 more definitions for you. Active, passive, bilateral and unilateral. Bilateral and unilateral. Done, sir? Even I can say simply, sir, lumped versus distributed. Simply we can say low frequency. Lumped means low frequency, high power electrical circuits. Low frequency, high power electrical circuits. Distributed means high frequency, low power electronics circuits. High frequency, low power electronic circuits. So finally, electrical people, high power. Electronics people, low power. Immediately they will say, sir, we are with high frequency. Then we say, your high frequency device will work only by introducing with, or only by introducing your socket with our 50 Hz frequency. Now hope you clearly understand. I belongs to electrical dears. Done. Jai electricals. Jai power. Okay. Fine, sir. Let us go to some questions on this. Let us do some previous gate questions on this topic and I conclude Ohm's law. Ohm's law is not simple here. Ohm's law is not simply I equal V by R. Ohm's law is not simply, yes, let me come to this point. Yeah. Ohm's law is not simply V equals to I into R. Some previous questions dear. Faster. Right. Suppose the characteristics are like this. Come on, tell me. Let me zoom this. Only the first one. Let me zoom this for you. Yeah. Still let me zoom this. I want to explain a lot of points for this question here. Okay. Right. Yes. Come on. Answers please. Come on. Is this linear or non-linear? Yes, everybody answers. Linear. Previous questions, sir. Questions and answers fast. Linear. Passive or active? Slope. Slope is positive. Slope is positive. Slope positive means passive. Linear, passive and bilateral. Linear, passive and bilateral. Suppose if the shape is like this. This one non-linear. Why non-linear? Not passing through origin. Passive or active? Passive. Bilateral or unilateral? Not bilateral, not unilateral. Next, one more point. Let me use green color pen. Suppose the characteristics are like this, say. The characteristics are like this, say. Okay. Now you tell me, what is this? Linear. Active or passive? Slope you are getting negative. Slope you are getting negative means it is active element. It is what element, sir? Active element. Bilateral or unilateral? Perfectly bilateral. Perfectly bilateral. Suppose, using pink pen, sir, suppose the characteristics are like this, say. Passing through origin or not passing through origin? Not passing through origin. What is this? Non-linear. Active or passive? Slope is still negative, na? Active. Next, bilateral or unilateral? Not bilateral, not unilateral. Clear? Clear, sir? Please have a look at this. Perfect. Next. Next, let me use blue pen. Blue is much comfortable, dears. Even you can see it properly. Suppose the characteristics are like this. Come on, tell me. What is this? Linear or non-linear? First, non-linear. See, linear, non-linear, if you ask me, strictly speaking, from this point to this point, linear. Black. Yeah. See, from this point to this point, linear. Okay. If you ask me globally, non-linear. Examiner interest is globally only. Okay. Right. Globally, non-linear. Next, active or passive? Passive. Next, bilateral or unilateral? Not bilateral. Why not bilateral? Not conducting equally in both directions, na? Not conducting equally in both directions. Why not unilateral? Conducting in the other side. Unilateral means what? It has to conduct only in one direction. Diode, sir. Diode plus 10 volts suppose given to diode, say. What happens? Forward bias, it will conduct. If you reverse the polarities, will it conduct? No, it won't conduct. It won't conduct, sir. So, diode is the best example for unilateral. Resistor is the best example for bilateral. Any doubt you are getting for bilateral and unilateral, have a reference of resistor and diode. That's it. Sir, I want to make this graph bilateral. For that, what I do? What I do is, I'll take a straight line, saturation, both sides. Which element is having this characteristic? Come on, electricals. Track is having these characteristics. Okay, right. Tell me, what is this? Passive, linear, non-linear, non-linear globally. Non-linear globally. Okay, next. Come on, sir. Next, one more point, please. Globally, bilateral, unilateral? It is bilateral. Sir, I want to discuss one more point here. What is that point? Blue pen. Active or passive is defined at a point. I am repeating my statement. Active or passive is defined at a point. We can't say globally or locally. See, at this point, Suno please. Active or passive can be defined at a point. At a point. If you ask me, here, passive, here, passive, here, passive, here, passive, here, passive, here, passive, here, passive. Passive, sir. Okay? Right. Active or passive is defined at a point. Okay? Right. Next, one more curve. Two important models are there. Let me explain those two important models. Sir, yes, let me cut off this line here. Let me cut off this line. Okay? Right. Fine. Two important models. V-shape curve. V-shape curve. Very, very important, sir. Many coaching institutes has given wrong answer for this. It's by open challenge. They have given wrong answer. Bilateral, unilateral, they have understood wrongly. They have given wrong answer. I have all the proofs with me. Done, sir? Why they understood wrongly? Let us clearly analyze. Suno, please. Tell me, sir. He is asking whether it is linear or non-linear. Okay. Tell me. Minus infinity to 0. If you see only from here to here, linear. Next. 0 to plus infinity. If you see from here to here, linear. Here to here, linear. 0 to plus infinity, linear. 0 to minus infinity, linear. Okay. If you ask minus infinity to plus infinity, how to say? Globally. Globally. Come on. Non-linear. Over. Next. For all this region, slope is negative. Slope negative means active. For all this region, slope is positive. Slope positive means passive. I told you clearly. Here, if you ask at this point, passive. At this point, passive. At this point, passive. At this point, passive. Active, 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 active. I can say from here to here or from here to here. He has not represented any point, sir. Did I represent any point? Did I represent any point? No. Examiner has not given any point there. Means what we can say, sir? Again, globally. Can't say. Can't say. We can't say. Examiner has to represent a point. Suppose if I give this point and if I ask whether it is passive or active, you will say at this point it is passive. Sir, I am active or passive is at this point. For all this session, I am active. At night, I will sleep. Again, after 1 month, we don't know, sir. We don't know whether we are active or passive. We don't know anything. Yes or no? Active or passive is defined at this point. Yes or no? Next point, please. Coming to linear or bilateral or unilateral. Bilateral or unilateral. Not bilateral. Not unilateral. Why not bilateral, sir? We don't have any symmetric graph in the third quadrant, na? That's why not bilateral. Why not unilateral? Conducting in the other side also, na? Conducting in the other side. Similar graph, sir. Students used to ask me, sir, please give some homework, sir, please, sir, give some homework, sir. Okay, take this problem as homework. Sir, answers, sir. If it is offline, we can come and meet you. Online, no, sir. Okay, answers, copy paste. Whatever the answers we got here, copy paste answers. Okay? With a small change here, the small change. That is, tell me please. It is a U-shaped curve, parabolic curve. Tell me please, here to here, linear or non-linear? Here also non-linear. Here, non-linear. Coming to here, active. Here, passive. Come on, not bilateral and not unilateral. Okay? Not same answers dear, it will change non-linear and non-linear. Whereas here, linear, nah? This is linear. Up from here to here, it is linear. Only from here to here. Globally non-linear. Here also, locally here also non-linear. Globally also non-linear. Finally, the conclusion, linear, non-linear, we speak globally. Active, passive, defined at a point. Bilateral, unilateral, please follow as per the definitions. Best examples, resistor as well as diode. Fine, sir. SCR. SCR. Yes, linear or non-linear? SCR. Come on. Linear or non-linear? Bilateral, unilateral. SCR is a unilateral device, dear. It's a unilateral device. So with this, some basic definitions completed. Now let us enter into the real circuit of Ohm's law. In another 10 to 15 minutes, we are going to conclude this. Very important, sir. Let us go with Ohm's law, very first circuit. I used to draw this circuit, dear. The very first circuit, Ohm's law. My first class Ohm's law. Even I go to transients, I used to say my first class Ohm's law structure. Come on, dears, tell me. 10 volts is given. 1 ohm. Now tell me how much current flows. Relax, buddies. How much current flows? 10 amperes flows here. When 10 amperes flows, what is the value of drop? 10 volts. This is potential difference. This is potential drop. Now what I am doing? I am increasing this source value to 20 volts. Means what happens here? 20 amps flows here. What is the value of drop, dears? 20 volts. 20 volts. Next I am doing, I am changing this to 5 volts. Now what happens? 5 amps flows here. What is the value of drop? 5 volts. All these three we call as potential difference. All these three we call as potential drop. So here the beautiful conclusion, as potential difference increases, current increases. As potential difference decreases, current decreases. This is what I proportional to V. As V increases, I increases. As V decreases, I decreases. As potential difference increases, current increases. As potential difference decreases, current decreases. One more circuit here. Now I want to vary the resistance value. Let me slide this. Yes. As potential difference. Now let me change the resistance values here. Yes. Tell me please. Sorry. Yes. How much current flows here? 10 amps. What is the value of drop here? 10 volts. Now, fast. I am changed to 2 ohms. What is the value of current here? 5 amps. What is the value of drop? What is the value of drop, sir? Still it is 10 volts. Next, if I change this to some 0.5 ohms, how much current comes? 20 amps. Still, what is the value of drop? 10 volts. Why, sir? 0.5 into, so no please, 0.5 ohms. 20 into 0.5. 10 na? V equal to I into R here. So here one beautiful conclusion, sir. This is potential difference. RL value I am changing 1 ohm, 2 ohm and 0.5 ohm. When ideal voltage source connected to variable load, load voltage is always equals to source voltage. Load voltage is always equals to source voltage. Very important, yes. So very important structure. Almost all the single source problems, the final structure is this. If you understand this perfectly, yes, Ohm's law is over. Clear, sir? Next, let me draw the circuit for one more time, sir. One more time. Please accept for my sake. 10 volts, 1 ohm. Everybody, please tell me what is the value of current that flows here, sir? 10 amps. What is the value of drop here? 10 volts. Current here? 10 amps. Current here? 10 amps. What is power delivered by this source? Power delivered by 10 volts is 100 watts. What is power absorbed by 1 ohm resistor? Come on, engineers. We are into IR. How much? 100 watts. Also equals to IR square R. How much? 100 watts. also equals to VR square by R. How much? 100 watts. From this I want to give one statement. PDL equal to POPs. Huh? What is this PDL and what is this POPs, sir? PDL means power delivered. POPs means power absorbed. PDL equal to POPs means Telegrams theorem verified, na? Come on, dears. Telegrams theorem is over. What is charge? Charge equals to I into T. Suppose T given some 2 seconds, say 10 into 2, 20 coulombs of charge. Over. Charge is calculated. What is energy, sir? Power into time. Say T given as some 2 seconds. Same 2 seconds. 100 into 2. 200 joules. 200 watt seconds. Over. Come on, sir. Entire network subject, what we calculate? Current and voltage. Once you know current and voltage, power can be calculated, charge can be calculated, energy can be calculated, provided if time is given. Getting the point, yes? Simple circuit here. Simple circuit. Done, sir? Right. Lastly, I want to draw the graphical representation of this Ohm's law or the DC in short. Suppose V is like, come on, tell me, sir. Okay. T, V is like this, say. Next. Current is a time invariant. Now, what is power, sir? What is power P? Power P equals to V into I. Power P equals to V into I. If anyone asks me energy for a particular time T1, energy definition already explained, yes. P into T1. Up to particular time, this area gives energy. Energy equals to P into T. Now here interesting question. Ohm's law is applicable only for lumped circuits or even for distributed circuits? Ohm's law applicable for lumped or distributed? Ohm's law is derived from distributed form, sir. What is the distributed form of Ohm's law? What is the distributed form of Ohm's law? J is proportional to E. What is J equal to? Proportional replace it with sigma E. What is this J? Current density. What is E? Electric field intensity. Current per unit area equals to sigma into, come on, voltage applied throughout the length of the conductor. What is I from this? Sigma A by L into V. What is I, which you have learnt? Lumped form of Ohm's law. 1 by R into V. Compare this 1 by R and this. What do you get? 1 by R equals to sigma A by L. What is R from this? What is R from this? Let me slide this. Yeah. What is R from this? L by sigma A. 1 by sigma. This is sigma means what? Conductivity. Rho L by A. So what is distributed form of Ohm's law? J equal to sigma E. Lumped form of Ohm's law. I equal to V by R. Ohm's law is applicable both for lumped and distributed. Yes, very, very important. N number of times this question is asked in exams. Staff selection committee, Genco, Transco, this question has come. Ohm's law is applicable both for lumped and distributed elements. Done, sir? Right. What are the limitations of Ohm's law? Limitations of Ohm's law. Ohm's law is applicable only for linear elements, but not for non-linear elements. Example, diode, transistor, all these elements, Ohm's law is not applicable. Fine, sir. This is what Ohm's law. This is what Ohm's law is. Practice, work hard, dears. Okay. The secret of success is your hard work. The secret of success is your hard work. Revision is mother of remembrance. Revision is mother of remembrance. Sir, we are here to give infinite service for you, but you should have two things. One is patience. Very, very important thing. Patience. When you are sitting at your home, patience. That patience is important. Have enough patience, dear. For just this 6 to 8 months, we are here to make you rankers. Second thing, you should have data. The data has to be there. We are teaching infinite concepts. To see all that, the data should be available with you. Okay, we are making the videos available for you for almost 14 months, dear. Please make use of our concepts. Done, sir? This is what Ohm's law. Next class, we go with K loss. Brother, K loss. Yes, I will make K loss as additions for you. K loss, I will make it additions for you, dear. Just additions, just additions, just additions. Fine? To know the further concepts of network subject, stay tuned to networks class. Stay tuned to Shamsa's class. Done, dears. Thank you. All the best.